In this lecture, we will solve some more problems on Laplace transform. In this problem, we need to find the Laplace transform and the ROC of the signal e raised to minus t u of t plus e raised to minus 2t u of t. Considering a reference formula, we have Laplace transform of e raised to minus at u of t is equal to 1 divided by s plus a. So finding the Laplace transform of the individual terms, we have Laplace transform of e raised to minus t u of t plus the Laplace transform of e raised to minus 2t u of t. Now for the first signal, Laplace transform is 1 divided by s plus 1 plus for the second signal, we have a is equal to 2. So the Laplace transform is 1 divided by s plus 2. Since we have u of t term which is a right-sided signal, we get the ROC for the first term as real of s greater than minus 1. For the second term, we have real of s greater than minus 2. Now, in order to find the ROC of the complete signal, first draw the S-plane. For the first term, we have real of s greater than minus 1. So draw a pole at minus 1, draw a line passing through it, and the shaded region is drawn towards right side from this pole. For the second signal, we have real of s greater than minus 2. So draw a pole at minus 2. Again, draw a line passing through it, and the shaded region is again towards right side. Now, the common region of these two signals should be considered as the ROC of both the signals together. So we know that the common region for these two terms is starting from minus 1 towards right side. So we have ROC as real of s greater than minus 1. Now we will see Laplace transform and the ROC of e raised to minus 2t u of t plus e raised to minus t by 2 u of minus t. We know that Laplace transform of e raised to minus at u of t is 1 divided by s plus a. And the Laplace transform of minus e raised to minus at u of minus t is equal to 1 divided by s plus a. Here, we don't have a minus sign for the signal, so we have e raised to minus at u of minus t, and that negative sign can be added in the transform, so we have minus 1 divided by s plus a. These two we can use as a reference formula which we have already derived for previous problems. So we have Laplace transform of e raised to minus 2t u of t plus e raised to minus t by 2 u of minus t. We can find the Laplace transform of the individual signals here. So we have Laplace transform of e raised to minus 2t u of t plus the Laplace transform of e raised to minus t by 2 u of minus t. For the first signal, comparing it with the above reference formula, we have a's value as 2. So we can write the Laplace transform as 1 divided by s plus 2. Now for the second signal, comparing the second reference formula, we have a's value as 1 by 2. So we can write it as minus 1 divided by s plus 1 by 2. Now for the first transform, we have pole is equal to minus 2. And since the given signal is having a u of t term, that is a right-sided signal, we can write real of s as greater than minus 2. For the second signal, we have a pole at minus 1 by 2 and the signal is having u of minus t term, which is a left-sided signal. So we have real of s less than minus 1 by 2. Now let us find the ROC for the complete signal. So first mark the poles. So we have here for the first signal pole is minus 2, and for the second signal the pole is minus 1 by 2. Draw a line passing through the poles. Now for the first signal, the signal is varying as real of s greater than minus 2. So it is a right-sided signal. And for the second signal, the ROC is real of s less than minus 1 by 2. So from the pole minus 1 by 2, the ROC is left-sided. Now, the common region of these two signals should be considered as the ROC of both the signals together. The common region is varying from minus 2 to minus 1 by 2. So, the ROC of the complete signal is minus 2 less than real of s less than minus 1 by 2. Sixth problem is find the Laplace transform and ROC of e raised to minus 2t u of minus t plus e raised to phi t u of t. Using some reference formulas, we have e raised to minus at u of minus t gives us a Laplace transform minus 1 divided by s plus a, and e raised to at u of t gives us a Laplace transform 1 divided by s minus a. Now for the first term, since we have u of minus t term, it is a left-sided signal. So we have ROC as real of s less than minus a. For the second term, since we have u of t term, which is a right-sided signal, we have ROC as real of s greater than a. Using this, in order to solve the problem, we have Laplace transform of e raised to minus 2t u of minus t plus e raised to phi t u of t. Finding the individual term Laplace transform, we have for the first term, using the above reference formulas, we get Laplace transform as minus 1 divided by s plus, here a's value is 2. So we have s plus 2 plus for the second term, using the reference formula, we have a is equal to 5. So we can write it as 1 divided by s minus 5. Now for the first term, we have real of s less than minus 2. And for the second term, we have real of s greater than 5. So when we want to find the ROC for the complete signal, first mark the poles in the S plane. So we have for the first term we have a pole at minus 2, and for the second term we have a pole at 5. For the first signal, ROC is varying from the pole minus 2 towards left side, and for the second signal, ROC is varying from the pole 5 towards right side. So if you observe the ROC, there is no common region for these two signals. So you can say there is no ROC for the given signal. Thank you.